I'm going to show you is how to thread a balloon onto a skewer. It looks really cool and it's a great party trick. To do this, we start by taking an ordinary balloon, blow it up, and tie a knot in it. If we look at the bottom here, you can see it's a deeper colour yellow. This is because the rubber's thicker and not stretched out so much, so it's under less strain. Same goes for this point here, right at the top. And it's here we're going to be pushing our skewer through. So take a skewer, make sure it's nice and smooth with no rough edges, and coat it with a thin layer of washing up liquid. This will help lubricate it and seal it onto the balloon. You should now be able to push it into the bottom of the balloon without it popping. Then line it up with a thick part at the top and carefully push it on through. And there we have it, a balloon threaded onto a skewer. Pretty cool, huh? And when you're done, you can pull the skewer out and pop the balloon. It's a great trick to do, and it looks really impressive. Here's another cool trick for pushing sewing needles into a balloon. Take a strip of tape and stick it to the surface of the balloon like this. This will add a lot of strength to the wall of the balloon, so rather than popping when we poke it with a needle, it should hold it together. So take your needle and push it straight through the middle of the tape into the balloon. And it didn't burst. And you can even do more than one needle. I did 4 altogether. It's a really cool experiment, but be warned, if the balloon did burst, the needles could fly anywhere. So make sure you wear safety gear. For the next one, I'm going to show you a really cool experiment to learn about density. And after that, we're going to look at some more experiments too. If you're enjoying this video, please do consider subscribing, it really does help me. And I want to say a huge thank you to everyone who's become a Dave Hacks channel member, and all those people who have also given me a super thanks. It really is very generous, and I massively appreciate it. Now on to the experiment. So for this one, I'm taking a drinking glass, pouring in some water and food colouring. Then I'm adding some syrup, and you can see it sinks straight to the bottom of the glass. I added a little bit more water to make the layer a bit bigger. Then finally fill the glass up with some oil, and leave it to settle for about 15 minutes. You can see the oil floats on top. These liquids separate out into different layers because they're different densities and they don't mix. The syrup has the highest density, so it sinks to the bottom, and the oil, which has the lowest density, rises to the top. If I drop in this dense metal nut, you can see it sinks right to the bottom. But if I drop this grape in, it sinks through the oil and water but sits on the syrup. This is because the syrup is denser than the grape. Pretty cool, huh? Now if I take this plastic bottle top and drop it in, it slowly sinks through the oil and sits on the water. And finally, if I take this piece of sponge and drop it in, it sits on the top. The oil is denser than the sponge. You could try dropping different objects in to see which fluids are denser. Next I'm going to show you how to make a Cartesian diver, which can sink then float back to the top. To make this, I'm using a plastic pipette and a metal nut. Thread the nut over until it seats against the bulb at the top, then cut the tube just below with some scissors. I actually found this nut was slightly too large, so I'm replacing it with a smaller one, and cutting it down some more. Then I fixed it in place with my glue gun. After it dried out, I tested it in some water, and you can see it floats perfectly. It bobs up and down nicely, and if I push it down with my finger, it floats straight back up to the top. Next I'm filling up a plastic bottle with some water. Then I dropped in our pipette, and screwed the lid back on. Now watch what happens when we squeeze the bottle. It sinks to the bottom, release the bottle, and it floats back up. So what's happening here? Inside the pipette bulb is a bubble of air, and when you squeeze the sides of the bottle, you increase the pressure inside. This compresses the air inside the pipette bulb, and this makes it increase in density. And the increase in the air density, combined with the density of the bulb and the metal nut, is now greater than the density of the water around it, so it sinks to the bottom. When we stop squeezing the bottle, we release the pressure, which allows the air bubble to expand back to its original size, and the whole thing floats again. And you can even make your own diver out of a drinking straw. Cut it in half and fold it over on itself like this. And I'm using a paper clip for a weight. And make sure it floats. Then add it to the bottle. Or if you wanted to, you could use some plasticine around a straw to make your own diving figure. Then try it out by giving the bottle a squeeze. And because they're all made differently, they have different characteristics, so they all behave slightly differently. For the next experiment, I'm taking an aluminium drinks can and I'm gently abrading the surface to remove any contamination, and I'm going to demonstrate how it reacts with gallium metal. This is non-toxic and solid at room temperature, but I can heat it up in some warm water, and after a couple of minutes it turns into a liquid. I'm putting some into a syringe, and I'm adding it to the top of the can. This should react with the aluminium. After about half a minute, the gallium burst the can and released the pressure, blowing a blob of gallium clean off the surface. And after a few minutes, you can see the gallium has turned black where it's reacted with the aluminium. And look what happens if I try and add some more. It just disappears through the surface. Crazy, huh? After an hour, I tried to open the can, and the ring pull just came off in my hands. And the top of the can has just melted. Crazy, huh? I can sort of peel it back, and the Coke is still inside. I used a skewer to have a little poke around and peel it back. And this is a great demonstration of how gallium will just destroy aluminium. Oops, I think a piece fell down inside. And I'm obviously not going to drink this. Next I'm going to show you how to make a really cool candle seesaw. Take a candle, then use a knife to remove some wax from the bottom of the candle to expose some wick. Then work out roughly where the balance point of the candle is and put a mark in the wax. Then take a needle, grip it firmly in some pliers, and heat it up with a lighter. Then push it straight through the middle of the candle on the balancing point where we made our mark. Next, take a couple of small glasses and balance the candle in between them like this. You'll probably find the candle falls to one side because it's not yet perfectly balanced. So lift up the heavy end and light that side of the candle. As it burns and the wax drips, it should become lighter and start to reach balancing point. And when it does, use your lighter to light the other side. After a minute or two, when the flames have shaped the wax, you should be able to give it a rock and start the seesaw. If it becomes too quick, you might find it sticks like this. So carefully release it and let it go again. And to stop it happening again, you can push the two glasses together so they're just touching the candle. This friction should slow it down and give you a more uniform seesaw. You can see a drop of wax running off every time it goes down. It's a really cool little science trick, and if you do try this, make sure you try it somewhere safe where nothing can catch fire. You can also do it with some birthday cake candles. I made a small base on the table using some plasticine, then stuck in a drinking straw vertically. I heated up a paperclip and melted a hole through the centre of another straw. Slid in some cake candles into some slots I cut, so it looks like this, and held them in place with a little bit more plasticine. Then I used a needle to pin it to the top of the vertical straw. It moves nice and freely, and you can balance it up by removing some of the plasticine. Then light the candles, and here we go. As one candle gets shorter and lighter, it rises to the top. And the candle that's at the lower end melts quicker because it's closer to the hot part of the flame. When a drop of wax dribbles off, it gets lighter, so it rises to the top. I hope you've enjoyed these fun science tricks. Just make sure you blow the candles out before you get to the end, because you don't want to burn the straws. To see more, you can click on the links or take a look at my YouTube channel page. Stay safe, have fun, and as always, thanks for watching.